Now we have another geometrical situation. A right circular cylinder is inscribed in a cone with height h and base radius r. Find the largest possible volume of such a cylinder. When we're told that the height is h and the radius is r, then I'm expecting to see probably both h and r in my answer. As usual, I'm going to start with a visual of the situation. All right, here's our cone. Inscribed inside is a right circular cylinder. And when we say inscribed, we mean that it's touching everywhere it possibly can be, right? We don't just have some cylinder hovering inside of a cone. Now you can imagine that this cylinder could be very stout, it could be very thin and tall, and each of these is going to have a different volume, and what we're looking for is the largest possible volume. A lot of times folks will start out with the volume of the cone, which is 1/3 pi r squared h. But that's not what we need. We're looking for the largest possible volume of the cylinder. So what we need is the volume of a cylinder. And in general, the volume of a cylinder is pi r squared h. You might say pi r squared h, and this is 1/3 pi r squared h. What madness is this? Whenever you've got a shape that tapers to a point, its volume is 1/3 of the volume of the shape that it would be if it didn't taper. So a cone, if you think about it as being based on a cylinder, but then tapers, is going to be 1/3 the volume of a cylinder. Just to bring that point home as an aside, we know the volume of a box is length times width times height. If you were to inscribe a pyramid inside the box, then the volume of the pyramid would be 1/3 length times width times height. Back to what we're looking at. Folks, I wrote this down as volume of the cylinder is pi r squared h, but I don't want there to be any confusion. This r squared and h can't possibly be this r and this h, because clearly the cylinder has dimensions that are smaller than the cone. Let's label those dimensions for the cylinder. I'm going to say that the radius of the cylinder is x, and I'm going to say that the height of the cylinder is y. So in our case, the volume of our cylinder is going to be pi x squared y, which is of course too many variables. I need a relationship between x and y so that I can trade out one of them, probably y, because we have this x squared. Staring at this, how can I come up with a relationship between x and y, like some sort of fixed equation? We could stare at it for a while, and the answer may or may not come to light for us, but I'm going to help you out by drawing one line segment. There it is. Does that help? Okay. How about if I draw another line segment? How's that? Now I have a large purple triangle. That large purple triangle has dimensions, well, base dimension of r and a height of h. It would be great if I had a smaller triangle and then be able to use similar triangles. And as it turns out, I can make a smaller triangle up at the top of the cone. Now for that smaller triangle, the base length is x. This vertical length, though, is clearly not y. But if this is h and this is y, then this is h minus y. And now I can use similar triangles. So I can say like h minus y is to x as h is to r. Doesn't matter how I set up the proportion as long as I have corresponding things in corresponding places. Now I said we were probably going to solve for y, but looking at this, it's probably going to be easier to solve for x. So let's go ahead and do that. X is going to be equal to r times the quantity of h minus y divided by h. Now I'm thinking ahead though. Remember, once I have everything in terms only of one variable, I'm going to differentiate. So I'm looking at this expression here. Do I really want to square it, substitute x squared FOIL up here, distribute a y. It can all be done. It's totally fine. But just as for another option, I'm going to go ahead and solve for y. See if that's better for us. That's going to give me h over r times x is equal to h minus y, which would mean that y is equal to h over r times x minus h. No, switch those around. Y is h minus h over r times x. I think I like that better. Okay, so I'm going to use that expression for y. We're going to replace y. So I have volume is equal to pi x squared. And look, I have h's in both terms here, so I'm going to factor out the h. And I'm left with 1 minus 1 over r times x. Oh yes, this is much preferable. Okay, so v of x is going to be pi h times x squared minus 1 over r x cubed. Now we're at a place where I'd like for you to go ahead and finish this problem. Come back when you're done. Starting with v is equal to pi h times x minus 1 over r x cubed. I differentiate and get v prime of x is equal to pi h times 2x minus 3 over r x squared. It looked kind of bad a few minutes ago, but we just used the power rule here. And if v prime of x is to be 0, then ultimately x is going to be 2/3 r. And so we're saying that x here is going to be 2/3 of this radius. So this picture isn't to scale, but that's okay. We were asked for, let's go back up here. We were asked for the largest possible volume. And so I'm going to put 2/3, there it is, 2/3 r into the expression for volume and end up with 4/27 r squared. So that's our largest volume. Now, a few minutes ago, we said that the volume of a cylinder was 1/3 pi r squared h. Does our answer make sense? Here's the deal. The cylinder, excuse me, that's the volume of a cone. My bad there. The volume of the cylinder inside the cone can't be any bigger than the volume of the cone. Do we have that situation here? Well, 1/3 in terms of a denominator of 27 would be 9 over 27. And so 4/27 pi r squared is smaller than the volume of the cone, and so the answer does make sense.